Hello, I'm Niklas Hjert and I'm going to give you a brief demonstration of the European Eutrophication Control, a web application developed by the SMHI for the Switch On project. The purpose of this application is to provide an analysis and scenario tool for eutrophication of inland waters. The application visualizes nitrogen and phosphorus transport calculations by the eEUTCON hydrological model. These calculations will reveal the sources of nitrogen geographically and sector-wise for any point in a catchment. Now the first thing that you need to do as a user is to define your point of interest. For this purpose, let's choose a catchment, for instance, in Italy. Let's choose the Lago di Como, just north of Milan. As I select this lake, a graph is highlighted on the screen, and you can also see a source apportionment on the right hand corner for Lake Como regarding the phosphorus transport. You can also switch to nitrogen, and you can see the source apportionment for nitrogen immediately. Let's go back to phosphorus. Now what the graph in the map is showing is the relative contribution from each of the catchments upstream of Lake Como to Lake Como. So each of these circles now defines the accumulated load of phosphorus at this specific catchment. So we can see here that quite a lot of phosphorus is coming down River Adda in the northern part of the lake. We can also see the total sources, total phosphorus load at the outlet of Lake Como. The pie diagram in the right hand corner is showing us that the biggest contributor to phosphorus in Lake Como is the agricultural land. We can also select agricultural land on the left hand corner, and we can see the relative contributions of load from agricultural land to Lake Como. We can look at other sectors such as rural households, wastewater treatment plants, industry, and urban areas. Let's go back to all sources and just look at the second choice. You can actually choose what load to visualize. The current load is the accumulated load in each part of the catchment, but if you switch to the local net contribution to the point of interest, you will see how much each of the catchments is contributing to Lake Como. Okay, let's switch back to the accumulated load. And now let's think about measures to reduce the phosphorus load on Lake Como. Imagine, for instance, that we can plan a measure somewhere on River Adda to reduce the phosphorus loads on Lake Como, and we can test this by clicking on one of the catchments in River Adda, and we can see here that River Adda is yielding 130,242 kilograms per year to Lake Como. Let's say that we can reduce this in some magical way by 50,000 kilograms. So let's type in minus 50,000. Now you can see that the outlet figure is much reduced. It's now to 80,000 kilograms per year. And you can also see that in Lake Como, this actually means a 17.71% decrease in phosphorus load. Please note that you don't have to tell exactly what kind of measure you're doing, just the result of this measure and how it's affecting the point of interest. You could also enter other scenario or other measures. For instance, here we may be able to reduce the load by minus 10,000, and up here we might be able to reduce it by 2,000. What you can see now is all of these scenarios together will give a minus 21.96% decrease in Lake Como. I should add that you could also simulate an increase in load. For instance, if someone is planning building projects or golf courses in the catchment, this figure of minus 10,000 might turn out to be plus 10,000. So you can add 10,000 kilograms and you can look at the resulting load on Lake Como. And you can remove the scenarios by just clicking out the boxes, or you can mail the scenarios to someone else by choosing the link and then copying the web link and mailing it or sharing it with someone else. One last thing is that this is a highly interactive tool. You could also move the point of interest easily by selecting the flag and pressing your left key on the mouse and just dragging it to another point. And now you will have analysis of the source apportionment for this point, and you can see to the right hand corner what the circle diagram or the pie diagram is telling you about the sources. There is also a filter function which allows you to remove points that are not interesting for some reason. You can remove the small catchments with small contributions and to focus on the catchments with the larger contributions. Well, that's all for now. Thank you very much for listening.